Beneath your feet right now, the ground is frozen. Not here specifically, but across a vast geographic zone covering approximately 25% of all land in the northern hemisphere, the ground has been frozen solid for thousands of years. A satellite map of the northern hemisphere shows the permafrost zone highlighted in blue across Russia, Alaska, Canada, and Scandinavia. This zone is called permafrost, ground that has remained continuously below 0 degrees Celsius for at least 2 consecutive years. In some places, the frozen ground extends 80 meters deep. In the coldest parts of Siberia, the permafrost reaches depths of more than 1,500 meters. And inside that frozen ground, locked in ice and frozen soil, is something that changes every calculation scientists make about the future of the climate. Carbon, approximately 700 billion tons of it. Dead plants, dead animals, dead microorganisms, organic material that accumulated and froze over thousands and hundreds of thousands of years, preserved in the cold like the world's most consequential freezer. 700 billion tons of carbon. That is nearly double the total amount of carbon currently in the entire Earth's atmosphere. Nearly double. And on April 4th, 2026, 3 weeks ago, a sweeping study published in the journal Global Biogeochemical Cycles found that Arctic permafrost is already thawing dramatically. It is reshaping rivers. It is releasing ancient carbon into the ocean at accelerating rates. The thaw has already begun. Subscribe to Where on Earth and hit the bell. Now let us understand the full geography of what permafrost is and why it matters so much. The permafrost zone covers approximately 23 million square kilometers of land across the northern hemisphere. That is an area larger than the United States, Canada, and Mexico combined. Russia alone sits above the world's largest permafrost territory. Approximately 65% of Russia's entire land area is underlain by permafrost. The geography of Siberia, which we covered in our Russia geography video, is fundamentally a geography of frozen ground. Buildings in Siberian cities are constructed on special foundations designed to sit above the permafrost without melting it. Roads crack and buckle every spring as the surface layer thaws and refreezes. Oil pipelines run above ground specifically to avoid transferring heat into the frozen soil below. The entire infrastructure of Arctic Russia, Canada, and Alaska is engineered around the assumption that the ground beneath will stay frozen. Now let us understand what is inside that frozen ground. The permafrost zone stretches across ancient landscapes that were once tundra, grassland, and forest. Over thousands of years, dead organic material, grasses, mosses, plants, animals, and microorganisms accumulated on the surface. In most climates, this organic material would decompose quickly. Bacteria and fungi would break it down. Carbon would be released to the atmosphere. But in the Arctic, the temperatures were too cold for decomposition to proceed fully. The material froze before it could break down completely. Layer upon layer of partially decomposed organic matter was buried under more frozen layers. Compressed, frozen, preserved. For 10,000 years. For 50,000 years. For 100,000 years. Some permafrost deposits contain the frozen remains of woolly mammoths and other Pleistocene-era animals preserved for tens of thousands of years. In 2020, Russian scientists revived microscopic multicellular organisms called bdelloid rotifers from permafrost deposits approximately 24,000 years old. The organisms were frozen for 24,000 years and survived. The carbon-rich organic material frozen inside permafrost is similarly preserved, waiting. Now let us understand what happens when it thaws. As temperatures rise in the Arctic at approximately 4 times the global average rate, the permafrost begins to warm from the top down. The active layer, the upper layer of soil that naturally thaws every summer and refreezes every winter, is getting thicker. Deeper into the permafrost, the temperature is rising. As the permafrost warms past 0 degrees Celsius, the frozen organic material begins to thaw, and when it thaws, microbes wake up. Bacteria and other microorganisms that have been dormant in the frozen ground for thousands of years become active again when the temperature rises. They begin consuming the organic material. They decompose the ancient carbon that has been frozen since before human civilization existed, and as they decompose it, they release greenhouse gases. In well-oxygenated conditions, they release carbon dioxide. In wet oxygen-poor conditions, the waterlogged soils of Arctic wetlands and lakes, they release methane. And methane is where the real alarm begins. Methane is approximately 80 times more powerful as a greenhouse gas than carbon dioxide over a 20-year period. Not twice as powerful, not 10 times, 80 times. When permafrost thaws in wet conditions, the ancient organic material decomposes into methane that traps 80 times more heat per molecule than the carbon dioxide coming out of a car exhaust pipe. The April 2026 Global Biogeochemical Cycles study found that permafrost thaw in northern Alaska is already dramatically reshaping the hydrology of the region. Rivers are carrying more dissolved ancient carbon than at any point in the historical record. Runoff is increasing. The thawing season is stretching further into autumn. The ancient carbon being released is flowing into Arctic rivers and then into the Arctic Ocean. In the ocean, microbial processes convert dissolved organic carbon into carbon dioxide. Over 275 million tons of ancient carbon enter the Arctic Ocean from rivers every year, and the rate is increasing. Now let us understand the most alarming aspect of the permafrost problem, the feedback loop. When permafrost thaws, it releases carbon dioxide and methane. Carbon dioxide and methane are greenhouse gases. Greenhouse gases trap heat in the atmosphere. More heat warms the Arctic further. More Arctic warming thaws more permafrost. More thawed permafrost releases more carbon dioxide and methane. The loop feeds itself. This is not just a theoretical concern. The Arctic permafrost region has already become a net contributor to global warming in recent decades, according to research led by scientists at Stockholm University. From 2000 to 2020, the carbon dioxide absorbed by Arctic vegetation was largely offset by emissions released from thawing soil. The permafrost zone is already releasing as much carbon as it is absorbing, and that was before the accelerating thaw of the mid-2020s. Now let us understand the concept of abrupt thaw, the process that makes climate scientists most concerned. Most models of permafrost thaw assume the process will be gradual. The active layer thickens slowly over decades, a steady incremental release of carbon. But NASA-funded research found a second process called abrupt thaw that operates on a completely different timescale. Abrupt thaw occurs beneath thermokarst lakes. Thermokarst lakes are depressions in the Arctic landscape that form when ice-rich permafrost thaws and the ground collapses. Water fills the depression. The lake water insulates the ground beneath it from winter cold. The permafrost under the lake thaws year-round. Organic material that has been frozen for thousands of years is suddenly exposed to warm water and decomposing microbes simultaneously. The carbon release is not gradual, it is explosive. NASA research found that abrupt thaw processes increase the release of ancient carbon by 125 to 190%, compared to gradual thawing alone, more than double. And critically, abrupt thaw was found to be just as significant under scenarios where humans reduce emissions as under scenarios where we do not. This means that even in the best-case scenario for human climate action, even if every country met its Paris Agreement targets, large methane releases from abrupt thaw processes in permafrost are still likely to occur. The permafrost feedback is not fully within human control. Now let us understand the geography of where the permafrost bomb is biggest. Siberia contains the world's largest continuous permafrost territory. The Siberian Arctic tundra and taiga forests cover millions of square kilometers of frozen ground. Beneath the Siberian lowlands, the flat plains of the Ob, Yenisei, Lena, and Kolyma river basins, the permafrost is ancient and carbon-rich. These river systems are already carrying increasing loads of ancient carbon to the Arctic Ocean. A decade-long study of 4 major Siberian rivers tracked the carbon they carry to the sea. The Ob, the Yenisei, the Lena, the Kolyma, all 4 rivers flowing northward from Siberia to the Arctic Ocean are carrying increasing quantities of ancient carbon mobilized by thawing permafrost. The Siberian lowlands are among the most carbon-rich permafrost landscapes on Earth, and they are thawing. Alaska has its own permafrost crisis. The April 2026 study found the largest increases in carbon export from thawing permafrost are occurring in northwest Alaska. The flat, low-lying terrain of northwest Alaska contains thick peat deposits, compressed layers of partially decomposed organic material that have been accumulating for thousands of years. As the permafrost beneath these peat deposits thaws, the peat itself begins to decompose. Peat is extraordinarily carbon-rich. The world's peatlands store approximately twice as much carbon as all the world's forests combined, despite covering only about 3% of Earth's land surface. When peat dries out, it can burn. In 2020, 5 wildfires scorched record areas of peat across Siberia and Alaska, doubling carbon emissions in affected basins according to NOAA data. Burning peat releases carbon that has been accumulating for thousands of years in hours. The permafrost thaw releasing methane, the peat fires releasing carbon dioxide. 2 processes feeding the same feedback loop. Canada also holds vast permafrost territories across the Northwest Territories, Yukon, and northern Quebec. The Mackenzie River Delta, one of Canada's great Arctic river systems, is already showing elevated ancient carbon in its flow. The geography of the permafrost time bomb stretches across 3 continents. Russia, Alaska, Canada, the 3 largest permafrost territories on Earth. All thawing, all releasing ancient carbon, all feeding a feedback loop that human emissions reductions cannot fully control. Now let us understand why this matters for the geography of everywhere else on Earth. The permafrost feedback loop connects to every other geography story in this series. More methane from thawing permafrost adds to the greenhouse effect that is already melting Greenland's ice sheet. Greenland melt disrupts the AMOC ocean current we covered, weakening the circulation that keeps Europe warm. Rising temperatures from permafrost methane accelerate the drying of the Amazon that we covered, pushing the rainforest closer to its tipping point. More carbon in the atmosphere means more ocean acidification, threatening the coral reef systems that support fish populations across the tropics. The permafrost is not a separate problem contained in a remote region. It is a second climate engine, burning fuel that humanity never lit, that is already running, that cannot be switched off once it reaches sufficient scale. Climate scientists have described the permafrost carbon as the sleeping giant of the climate system. For decades it slept. The Arctic was cold enough to keep it frozen. Now the Arctic is warming faster than anywhere else on Earth. The giant is waking up. The April 2026 study shows that the process is already well underway. Runoff increasing. Rivers carrying more ancient carbon than historical records have ever shown. Thawing season extending further into autumn. The vault that has been sealed for thousands of years is opening. What was frozen for 50,000 years is being released in decades. And here is the final geographic fact that puts everything in perspective. The 700 billion tons of carbon in the world's permafrost is nearly double the total carbon in the entire atmosphere today. If even a fraction of that ancient carbon is released over the coming decades, it adds a second wave of warming on top of everything human industrial activity is already causing. A second wave that no solar panel, no wind turbine, no electric vehicle can stop, because it is coming from the ground, from organisms that died before humans existed, from a geography of frozen carbon that is now thawing faster than any climate model predicted. The permafrost time bomb was always ticking. The clock is getting louder. Subscribe to Where on Earth for weekly geography that reveals the forces reshaping our planet. Hit the bell and drop your thoughts in the comments below. Because the world looks very different when you understand the geography that is thawing beneath the Arctic.